This question is from GATE 2014, Mechanical Engineering paper, Set 1, question number 9. A circular object of radius r rolls without slipping on a horizontal level floor with the center having velocity v. The velocity at the point of contact between the object and the floor is. For any wheel which is rotating with the angular velocity omega, the tangential velocity at any point on the periphery, we can mark it as Vp, that is tangential velocity on a peripheral point, will be equal to, Vp will be equal to omega into r. This is for any point on the periphery, right? So if we consider the base point also, it should be omega into r, but what should be the direction? The direction should be backwards. Magnitude will be same, omega into r. Of course, r is the radius of the wheel. Now it is being said that the wheel itself, the center point of the wheel itself is moving forward with a velocity v. There is a horizontal velocity given to the center point of the wheel. That means if we consider two separate motions, one is the rolling of the wheel, and another is the translation. So if the center point of the wheel is moving forward with a velocity v, every point on the wheel will be moving forward with the velocity of v. That is true. That means this bottom part is also moving with a velocity v. So on this side, we have omega r backwards, and on the forward side, we have v forward. So net velocity at point of contact will be, if let's say this point of contact is O, we can write velocity at point O, that is the point of contact of the wheel, will be equal to v minus omega r. So if we consider O as the origin, x-axis is towards right side, v will be positive and omega r will be negative. Now in the second part, we will have to see how v can be expressed in terms of omega and r. Now, if we use the concept of instantaneous center, O is the instantaneous center. That means velocity at this point, let's mark it C, center point C. Velocity at point C can be given as distance from the instantaneous center into the angular velocity of the wheel. So distance from the instantaneous center is OC into omega, will be nothing but the velocity at this point C, V. Now OC is of course equal to R, that is why V is also equal to omega R. If we put this here, we get velocity at point O is 0. So this is by the concept of tangential velocity, while this is by the concept of instantaneous center. Let's go back and mark the answer. The answer is option A, 0. To learn more about relative motion and instantaneous center, the concepts which we have used in this video, you can refer to the NPTEL video, Lecture 26, Relative Motion 3 and Instantaneous Center. It is by Professor K. Ramesh. He is from IIT Madras. I hope this solution will help you clear your doubt. Thank you.